All right, 288. That's 288. Doesn't look good. Did it again. All right, 288. We're going to solve polynomial inequalities. There's a couple ways to do these. If you're good at graphing polynomials, like you know how to graph them pretty well because that first quiz, when we found out, like, are they opening up or down? Where are the zeros at? Then you're going to do just fine on this, okay? Because you can use those skills with this. Now, what we're going to do is we're going to have a polynomial, and it's going to look like this. It's going to be f of x is greater than 0, for example, okay? And what we're going to do is we're going to try to find all the x values, that make the polynomial positive. Okay, make the polynomial positive. We did this already with quadratics in chapter P. But now we're going to open it up to all polynomials, really big ones. Okay? So if f of x is greater than 0, we're going to find all the values that make polynomial positive. Or if you're going to think about the graph, you don't get your calculator for this, but you know how to graph these things. You're going to think about where the polynomial is. Okay, so you could either do that or this. Where the polynomial is above the x-axis. Okay? The book has you doing a sign chart. I kind of do a little bit of both. So here we go. These are the steps that you're going to take to doing these. Number one, first thing you want to do is you want to factor it, or if it's already factored, leave it factored. Don't FOIL the whole thing out. You want to factor it and find the real zeros. Okay? Find all of the real zeros. We don't care about complex zeros for these. Number two. Then you are going to make intervals using those zeros. Make intervals. So if you have 3 zeros, that's going to make 4 intervals. Okay, it's going to split up the number line into 4 intervals. And then you're going to test for either positive or negative. Okay? All right. Now, you've done this before, so this isn't going to be that bad. But it's just going to be, bigger polynomials now. So here we go. You ready? Let's do it. F of x equals x plus 3 times x squared plus 1 times x minus 4 squared. Okay. And we are going to do 3 parts here. Okay, we're going to A, find all of the zeros of the polynomial. B, we're going to find out where this polynomial is positive. And C, we're going to find out where it's negative. Okay? All right, so let's start. So let's look at each of our different factors here. It's already in factored form, which is really nice. And so for part A, the zeros of this polynomial are, let's look at each individual factor. We have negative 3, x squared plus 1. I don't get any real zeros. Okay, we're looking for the real zeros. I don't get any real zeros from that factor. And then I get that 4 is a double, or a multiplicity of 2, whatever you want to call it. Okay? All right, so I only get 2 real zeros. So I'm going to make a sign chart. I'm going to plug in negative 3 and positive 4. Okay? Now, at those points right there give me a value of x equals 0. I'm sorry, y equals 0. Those are our zeros. I don't want to write x equals 0. Do I? I don't think so. There we go. Corrected my mistake. Okay, so negative 3 and positive 4. So now what we need to do is we need to test our intervals. There's 3 of them to test. So this is what the book suggests that you do. And I'm going to walk you through this way, see if you like it, and then see if you like your way, okay? So let's go ahead and test a point over here in this interval. So pick a number between negative infinity and negative 3. What are you going to pick? Probably -4. Am I right? Were you thinking -4? Yeah, me too. All right, so let's pick -4. And what we're going to do is we're going to test -4 in our polynomial up here. So we're going to go -4 plus 3. I'm looking at this right here. -4 plus 3 is -1. And then I have -4 squared, which is 16 plus 1 is 17. And then I get -4 minus 4 is -8 squared is 64. Now, it really doesn't matter what numbers these are. I'm not going to do 17 times 64 and waste my time. All I know is that is what, negative or positive? Negative. Okay. So this is negative in that interval. All right? Okay, so now let's pick a number between -3 and +4. I'm thinking x equals 0. Are you thinking x equals 0? Yeah. So let's plug it in. And now, instead of finding out like what the numbers are, let's just do positive negatives, okay? Because that's going to be easier for us. When we plug 0 in, we get 0 plus 3 is positive. 0 goes in here, we get positive. 0 goes in there, we're going to get positive, okay? Then I'm not even worried about what the numbers are. So I get, oh, yeah, positive, 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 because that's going to be -4 squared, which is going to give me a positive. And so this right here is going to be positive in that interval right there. Okay, one more interval to test. Let's pick a number on this side. Let's pick x equals, what do you think? 5. Yeah, me too. All right, x equals 5. When I pick x equals 5, I plug it in. I get 5 plus 3 is a positive number times 5 squared plus 1 is also a positive number times 5 minus 4 squared is also a positive number. Okay, you can do that pretty quickly. You don't care like what the numbers are like I did with the blue right here. We really just want to know positive. So that's going to turn out positive also. Okay, so now we're ready to answer their question. So for part B, it says that we need to find out where this polynomial is positive. What they're asking is, where is f of x greater than 0? Okay? Now, 0 is not positive, and 0 is not negative, so you cannot include the zeros. Okay? So this graph is positive from -3 to 4, union 4 to infinity. You see that? It's positive in between -3 and 4. These are zeros. And then it's also positive from 4 to infinity. And that's the way you write it. Okay? Now let's look at letter C. Where is this graph, f of x, where is it less than 0? It's less than 0 from -infinity till -3, and that's it. All right? Now, I'm going to change something real quick. Just a little bit of a change. What if they asked, where is f of x greater than or equal to 0? How does that change? Yes, brackets. So I would do -3 all the way to infinity. Do you see that? It's going to include -3 and it'll include 4, and it kind of connects those together, connects those intervals together. What about the other one? Bless you. What about f of x is less than or equal to 0? This one's a little tricky, okay? Because you will go ahead and include -3, but what else do you need to include? 4. And you know how they write that? They write it like this: union the point 4 with little brackety things around it. I know, it's kind of silly. Sometimes math is silly with all their notations and stuff. Okay, pretty good, right? All right, let me talk to you real quick about this. If you were going to, say, do it without doing a sign chart, which I do not mind, okay? If you were going to do it without a sign chart, you would go over here to -3, and you'd plot that 0, and then you would go over here to +4, and you would plot that 0. Okay. Now, what degree polynomial is this? Can you tell? 2, 4, it's degree 5. It's a degree 5 polynomial because this right here is squared. So you have, this is x squared, that's x squared, and that's an x. So it's degree 5 polynomial. and it's positive, and so you know it's going to go like that. Okay? We did this at the beginning of the chapter. And so you know this graph's going to go like this, and then 4 is a double. It actually does something weird there, but who cares? And then it bounces off. And so if you knew what the graph looked like, you know that over on this interval, it's below the x-axis, which is negative. Right here, from here to here, you're above the x-axis, which is positive, and then you remain above, so you're positive. Okay? So then you don't have to pick numbers and plug them in. It's up to you, though. The book likes the sign chart. You guys are good at graphing. You can do that. That's fine. Okay? It's up to you. All right, let's try another one. Number 2. Okay, we're going to find out where this polynomial, 2x to the third minus 7x squared minus 10x plus 24 is greater than 0. We're going to find out where this polynomial is positive. Now, these are all done algebraically. You're not allowed to graph them on your calculator. If you can graph them by using your brain, that's fine. I can't stop you from doing that. I wouldn't stop you from doing that. But this is not, you're going to graph it and go, okay, that's easy, right? So what they're going to do is they're going to give you, given that 4 is a 0 of the polynomial. Okay? 4 is a 0. So this is a third degree polynomial. I know that there are 3 zeros. They could be complex. But they told me that 4 is one of my real zeros. Let's go ahead and see if we can find the other ones. So let's take 4 and do what with it? Synthetic division. Nice. All right, here we go. We've got 2, -7, -10, 24. I'm expecting 0 at the end, are you? Yes. All right, bring down the 2. 2 times 4 is 8. Add it up, you get 1, 4, -6, -24, and 0. Yay. All right, so what I end up with is a quadratic. It's 2x squared plus x minus 6. Okay. I'm going to set this equal to 0 and find the zeros. This is factorable, so let's go ahead and do our star method. You got 2 times -6 up top, 1 on the bottom, 2 and 2. Two numbers that add up to -12 add up, or multiply -12 add up to 1 would be a +4 and a -3. And so that reduces to 1/2. So I get x plus 2, 2x minus 3, and then they gave me a 0 of 4, so I'm going to write x minus 4. So I'm trying to find out where that polynomial is greater than 0. Okay. I'm going to skip the sign chart if you don't mind on this one. I think this one is very easy to graph it. Okay? It's a basic third degree polynomial with 3 zeros, 3 real zeros. So we have a 0 over here at -2. Maybe you might want to write your zeros here. We have -2, 3 halves, or 1.5, and +4. So we'll go over here to 1.5, and 1, 2, 3, 4. Okay? Third degree polynomial, leading coefficient is positive. It's going to go up, through, and through. No, nothing fancy. There's no doubles. There's no triples. There's no crazy stuff going on. It's very basic. So here we go. We need to find the intervals of x where this polynomial is greater than 0. So I'm looking at this interval here, and I'm looking at this interval here. Okay? So my answers would be, or answer would be from parentheses -2 to 2/3. It's above the x-axis. It's positive. It makes all the y values positive. Union, what is that, 4 to infinity. And that's it. And I didn't have to make a sign chart. Okay? Do you like that better? Because you know how to graph, right? You're pretty confident in your graphing skills, I think. Either that or you're making a sign chart, like the book wants us to. I'd have to go like this, pick a negative, positive, and do it that way. But okay, let's try this one now. Number 3. Okay. F of x, this is different because you're going to see something like this and you're going to be like, what is this? X squared plus 7 and 2x squared plus 1. All right, so you get something like this. This is a 4th degree polynomial with a leading coefficient that's positive. And I try to find the real zeros, and what happens? There aren't any. So for this one, oh, and we're trying to find out when f of x is greater than 0. So the zeros, the real zeros of this, there are none at all. So you know what that means? That this graph does not touch the x-axis. It's going to be, and it's positive, okay, positive leading coefficient. It's going to be up here. I don't even know what it does. It looks like a ghost like that. Ooh. Anyways. So where is this thing greater than 0? Guess what? Everywhere. So the answer that the book will give would be negative infinity to infinity. You can write all real numbers if you want to. So any x that you plug in is going to be positive. It's going to make that polynomial positive. And then if the other question was where is it negative, you'd say no solution. Okay, so that's like a special one, a special case kind of a thing. What's going on over there? All right, so let's do another little special case one. Number 4. Let's say that we have a polynomial, f of x equals x squared minus 3x plus 3 and x plus 1 squared. All right, and we're going to do 4 things. We're going to find out when this polynomial is greater than 0. We're going to find out when the polynomial is greater than or equal to 0. And then we're going to find out when it's less than 0 and less than or equal to 0. Okay? All right, your first thing that you need to do is you need to find any zeros. Okay? Any zeros at all. So what I'm going to do is I'm going to try to factor that. It's not factorable. So then I got to go to the quadratic formula. It happens sometimes, bless you. X equals negative b plus or minus the square root of b squared minus 4ac. Now, all over 2a. If you look at this, you get 9 minus 12 inside the radical. Does that give us a real 0? No. It gives us a complex 0, but we don't care about those. That makes this lesson a little easier, right? So there are no zeros from that factor, from this right here. There are no real zeros, okay? How about from this one? Any real zeros? What makes that 0? Negative 1, and it happens twice, okay? So x equals negative 1, but it has a multiplicity of 2. That means it's going to bounce off like a parabola. Remember how that worked? Okay, so if you want to, you can make a sign chart. Now, if you were going to make a sign chart, you only have 2 intervals because there's only one 0, okay? And if you pick a number over here and you plug in, say, x equals negative 2, and you plug that in, you're going to get a positive times a positive. And then if you pick a number over here, I would probably pick x equals 0, like you would. You will get a positive times a positive when you plug that in. Okay. If you think about this as its graph, a negative 1 is its only 0, and this is a 4th degree polynomial with a leading coefficient that's positive, it's going to go something like that. And who cares what it does, but it does that. Okay? It's going to be above the x-axis except at negative 1. So let's go ahead and answer all these questions here. It doesn't look like that, by the way. It's better than that. I mean, it's like, it's more simple, but I just like to make it kind of weird. Okay, because I don't care what it looks like. I'm just asking, is it above, is it below? So if I had to answer question A, and question A is, where is this polynomial greater than 0, then I would need to say negative infinity to negative 1 union negative 1 to infinity. Okay? You could also say all reals except for negative 1. That would be fine. Now what's b going to be? Where is this polynomial greater than or equal to 0? Where is it? Everywhere. The whole thing, all real numbers, greater than or equal to 0. Think about this right here, it equals 0 right there. Everywhere else, it's positive. All the other intervals is positive. Okay, so then letter C, where is this polynomial less than 0? It's not, okay, so nowhere, no solution. And then D, where is this polynomial less than or equal to 0? One place, right? At x equals -1. You could write it like that. You could write it like this, -1 and that kind of thing. Okay? And that's it.